Let's look at problem 11 from OpenStax College Physics, Chapter 29. UV radiation having a 300 nanometer wavelength falls on uranium metal, ejecting 0.5 electron volt electrons. What is the binding energy of electrons to uranium metal? So let's start writing out our knowns and unknowns. So we're dealing with UV radiation, which is an electromagnetic wave. It's light, the particles that we're dealing with are photons. So the photons are striking uranium metal, and the wavelength of the photons is 300 nanometers. So we have lambda is 300 nanometers. And electrons are ejected. EV is electron volts, so it's a type of energy. So the type of energy that the electrons can have as they're ejected is kinetic energy. So the kinetic energy of the electrons is 0.5 electron volts. And the question is, what is the binding energy of electrons to uranium metal? So we're looking for the binding energy or the work function of the electrons. So this is a situation like this where you have a photon basically striking uranium, and an electron in the uranium is going to be loosened up and it will acquire a certain energy. So the equation for the photoelectric effect then is HF, the energy of the incident photon, is equal to the binding energy plus the energy that the electron that was loosened up from the uranium acquired. So it's conservation of energy. In this equation, we're looking for the work function, so W naught is HF minus kinetic energy. And we're not given the frequency, but we know the wavelength. So wavelength times frequency is the speed of light. So then we can have hc over lambda minus kinetic energy. And then we start plugging in numbers. So we know that h is the Planck constant, and that's 6.63 times negative 10 to the negative 34. C is 3 times 10 to the 8th meters per second. The wavelength is 300 nanometers, so that's 10 to the negative 9th meters, minus the kinetic energy. So that is in electron volts, 0.5 electron volts, but we have to convert that from electron volts to joules because the units of the quantity we have over here is in joules, since joules are the SI units. So 0.5 electron volts, there are 1.6 times 10 to the negative 19 joules in 1 electron volt. So we cancel out that unit. And when we plug in all these numbers, we end up with 5.83 times 10 to the negative 19 joules. And if we want to convert that back to electron volts, then we will do 5.83 times 10 to the negative 19th joules divided by 1.6 times 10 to the negative 19th joules per electron volt. Plugging in these numbers, we end up with 3.64 electron volts. So really, since the problem didn't specify what units to express your answer in, you can do either or both.